Shrinking. There's a deep and relatively unexplored world beyond what the human eye can see. The microscopic world is truly alien and truly fascinating. I'm delving further than the microscopic scale. I'm going to explore the potentials of working at a nanoscopic level, working at a level a billion times smaller than the average scale we work at today. This is nanotechnology. Nanotechnology means any technology on a nanoscale that has applications in the real world. Nanotechnology is the science of building small, and I mean really, really small. It's pretty difficult to imagine how small a nanometer is, but let's just take a moment to try and wrap our heads around it. The tip of a pen is around 1,000,000 nanometers wide, so nowhere near close. A single sheet of paper is around 75,000 nanometers thick. A human hair is around 50,000 nanometers thick. And I ran out of things to compare. Let's just take a different approach. If a nanometer was the size of a football, the coronavirus would be the size of an adult male. A donut would be the size of New Zealand, and a chicken would be the size of the Earth. In fact, on a comparative scale, if each person on Earth was the size of a nanometer, every single person on the planet would fit into a single car. A Hot Wheels car. You get the idea, nano is super tiny, we're talking subatomic. So that's how big, or rather small, a nanometer is. But why does it matter? Why look at really small things? Well, they ultimately teach us about the universe that we live in, and we can do really interesting things with them. When we move into the nanoscale, we can work with new domains in physics that don't really apply at any other scale. Nanoscience and nanotechnology can be used to reshape the world around us. Literally. Everything on Earth is made up of atoms. The food we eat, the clothes we wear, the buildings and houses we live in, our own bodies. Now, think for a moment about how a car works. It's not only about having all the right parts, they also need to be in the right place in order for the car to work properly. This seems obvious, right? Well, in pretty much the same way, how the different atoms in something are arranged determines what pretty much anything around you does. With nanotechnology, it's possible to manipulate and take advantage of this, much like arranging Lego blocks to create a model building or airplane or spaceship. But there's a catch, and here's where things start to really get interesting. The properties of things also change when they're made smaller. Phenomena based on quantum effects, the strange and sometimes counterintuitive behavior of atoms and subatomic particles, occur naturally when matter is manipulated and organized at the nanoscale. These so-called quantum effects dictate the behavior and properties of particles. So, we know that the properties of materials are size-dependent when working at the nanoscale. This means that scientists have the power to adjust and fine-tune material properties, and they've actually been able to do this for some time now. It's possible to change properties such as melting point, fluorescence, electrical conductivity, magnetic permeability, and chemical reactivity, to just name a few. But where can we actually see the results of this kind of work? Well, everywhere. There are numerous commercial products already on the market that you and I use daily that wouldn't exist in the same way without having been manipulated and modified using nanotechnology. Some examples include clear nanoscale films on glasses and other surfaces to make them water-resistant, scratch-resistant, or anti-reflective. Cars, trucks, airplanes, boats, and spacecraft can be made out of increasingly lightweight materials. We're shrinking the size of computer chips, in turn helping to enlarge memory capacity. We're making our smartphones even smarter, with features like nanogenerators to charge our phones while we walk. We're enabling the delivery and release of drugs to an exact location within the body with precise timing, making treatments more effective than ever before. There's quite the list, and that's only a few of the potential applications. Let's delve into a few of these in more detail. Nanotechnology has been pivotal in advancing computing and electronics, leading to faster, smaller, smarter, and more portable systems and products.